Show that the relation capital R in the set A is equal to set 1, 2, 3, 4, 5. There are only 5 elements in the set given by R is equal to set ordered pair AB such that modulus of A minus B is even, is an equivalence relation. Second question is show that all elements of 1, 3, 5 are related to each other and all elements of 2, 4 are related to each other. But no element of 1, 3, 5 is related to any element of 2, 4. There are actually 4 questions. First we have to prove R is an equivalence relation. Second we have to prove 1, 3, 5 are related to each other. Third we have to prove 2 and 4 are related to each other. And the next one is to prove 1, 3, 5 is not related to 2 and 4. So what we will do is we will write R in roster form. What's the condition? There are only 5 elements, isn't it? So what's the condition? Modulus of the difference is an even number. Modulus of the difference is an even number. So 1, 1 clearly element of R because modulus of its difference 1 minus 1 is 0. Its difference is, its modulus is 0. It's an even number. Same way 1, 2. Will 1, 2 be an element of R? No, because 1 minus 2 is not an even number. 1, 3 element of R. 1, 5 element of R. Same way 2, 1. Will it be an element of R? No, because the difference is an odd number. 2, 2 element of R, 2, 4 element of R. In the case of 3, 3, 1 element of R, 3, 3 element of R, 3, 5 element of R. In the case of 4, 4, 2 element of R, 4, 4 element of R. So these are the elements of capital R. Okay. Again with the 5, the elements are 5, 5, 1, again 5, 3, and 5, 5. So these are the elements of capital R. Okay. Again we have to check whether it is reflexive, symmetric or transitive. 1, 1 is an element, 2, 2 is an element, 3, 3 is an element, 4, 4 is an element, 5, 5 is an element. So it is reflexive. Again if we take 1, 3, 3, 1 is an element. If we take 1, 5, 5, 1 is an element. If we take 2, 4, 4, 2 is an element. That means it is symmetric. To check the transitivity, if I am taking 1, 3, I want to take 3, 1 starting with the 3, isn't it? So 1, 3 and 3, 1, then 1, 1 is an element of R. If I take a 1, 5, 1, 5 starting element with the 1, 5 is, we can select these two. So 1, 5 and a 5, 3 element of R. What about 1, 3? 1, 3 is also element of R, and that happens to all the cases, all the elements in R. That means R is transitive. Hence, what we can say is R is reflexive, R is symmetric, and R is transitive. Hence, it is an equivalence relation. The second question is we have to check whether, we have to show whether 1, 3, 5 are related to each other. 1, 3, 5 means we have to check whether 1, 3, 1, 5, 3, 3, 3, 5, 3, 1, same way 1, 1, 5, 1, 5, 3, etc. are elements of R or not. Check 1, 3 is there, 1, 5 is there, 3, 3 is there, 3, 5 is there, 5, 3, 1 is there, 5, 1 is there, 5, 3 is there. All the elements, that means each and every element of the set is related to each other. Otherwise, without checking in the R, just check whether the difference of the modulus of these two numbers are even. 1 minus 3 is minus 2, its modulus is 2. Even number. 3 minus 5 is minus 2. Its modulus is again 2. Again even number. 5 minus 1 is minus 4. Its modulus is 4, which is again an even number. So each element is connected to each other. Same way for the second set, 2, 4 and 4, 2. Check whether 2, 4 and 4, 2 are element of R. 2, 4 is here, 4, 2 is here. Therefore, they are also related. Related means it's an element of the relation R. Okay. Again, the next one is we have to check whether 1, 3, 5, we have to show that 1, 3, 5 is not related to 2, 4. That means we have to check whether 1, 2, 1, 4 element of R. Check, is 1, 2 an element of R? No. What about 1, 4? No. Check 3, 2 an element of R. Is 3, 2 there? No. What about 3, 4 is not an element? What about 5, 2 is not an element? What about 5, 4 is not an element? That means 1, 3, 5 is not related to 2, 4. But 1, 3, 5 is related to each other. 2, 4 is related to each other. And 1, 3, 5 is not related to 2, 4. Okay.